Okay, so along with the screenshot of some of the logic that shows the solution, we're going to go through the video, and then we're also going to import an add-on instruction. So here are your scaling compute instructions, and you'll see I've added them here, and then I've come over here and added the calculate the volume instruction as well. This is pasted into your lab document at the back last page as the solution. Well, now we want to import an add-on instruction, and in order to do that, because I've given you a scale add-on, which is a lot easier than programming it this way, so we're going to import and scale add-on instruction. So I'm going to click import add-on, use Windows Explorer to browse to where we have the scale.l5x file, and we're going to double click on that, and we should get an import, and we'll hit OK. And we had some errors. I'm not sure what these are, but we'll hit OK and go ahead and skip over those errors. And now that we've imported that, look at parameters and local tags here. Yeah, I'm not sure, but anyway, it will import. It took out some errors that it didn't like from the previous version of the software. And if we go into the logic, we'll see that I have the compute statement done for you right here in a nice little instruction. So we're going to drop that in because now we want to compute the liters per second. We're going to do liters per second out of our flow meter in Factory.io, so that's what we're doing. And in order to do that, I have to know what the max flow is in 1 second. And since we don't have any of the information on the flow meter, because it's a virtual flow meter, that's typically in the documentation. It says 20 milliamps equals 10 liters per second. So we don't know what that is, but that's typically in the documentation. But we don't know, so we're going to figure it out and get a good guess here. And so one way we can do that is we have to take into account we've got to run this thing at its max. And the only way we can do that, if we look here, and I will resize to fit our window, and right now I've filled up the tank and I've left it on. It's full. Okay, and it says level meter is all the way up, and then I'll hit the stop button and I'll hit the drain button. Notice that our flow meter takes off quite a bit, and we'll hit stop and we'll fill this back up. Alright, we'll hit stop here, and now we'll drain it, and we'll run up. Now we don't know what that, we know it didn't go to 10, but just for a brief second under the flow meter. But we'll go ahead and fill it up, and we're going to look. I've put some trap logic in there that's going to catch the difference in the volume. We've already calculated the volume, so if we know how many liters drain out of this tank in 1 second, then we'll know at the max flow meter reading that it's, so that whatever that value is in 1 second, we'll know that that's the rate at max of the flow meter. So with a raw value of 10, whatever we drain out of here, let's say if we drained 49 liters out of here in 1 second, we would know that a flow meter reading of 10 equaled 49 liters per second. And in turn, if we knew seconds, we could translate into minutes. Maybe we don't care about seconds, etc. So let's look at a little trap logic I've added here. So at this point the tank is completely full, and I've added this little trap logic, so when the drain command bit goes high, it counts for 1 second, fires a one-shot bit, so we only want to grab that data, and then it takes this. Right now we have 2339. That's how many liters we have in that tank full. So I'm going to write that value down. First of all, 2339. That's the volume full, all the way full. And what I'm going to do, make sure that doesn't change. Yep, that's what it showed up to be. I'm going to fire my drain bit, and when I drain it, it's going to count for 1 second and pull the differences, what the difference in liters in the tank is, and we can subtract those and know that our flow rate at max, because I'm watching the meter diagram here, I'm watching this flow meter rate, which is going to pretty much show a max value of 10, and so we'll know how many liters it drained in 1 second. So we're going to fire that bit. This isn't the best way. The best way is to actually have the documentation with the sensor, but since we don't have this, this is one way you can figure it out and get a rough estimate. And we'll begin draining, and we'll see that we grab this value. Now maybe I want to do an average. It might be a little bit more accurate if I were to do it for, let's say, 2 seconds, and then whatever value I got, divide by 2. Okay, so let's try that. So we're going to come in here and we're going to say, let's just grab it for 2 seconds, and then whatever answer I get from full to the current value dropped in 2 seconds, I'll divide by 2, and we'll just call that my max flow rate. So I'm going to fill my tank back up, and we'll see the tank filling all the way to the top. Here we have it all the way to the top. I'll stop the fill, and then I'll run it, and it should automatically count for 2 seconds, and I'll see that we had this value here, 2207. So I'll stop the tank. The reason we want to do it with a tank full is because that's the only way I can get this level meter to go to its max value. Okay, that may not always be the case, but we know if the tank is always full, the reading we get off the meter takes into account the static head pressure from gravity of the liquid in the tank, and so we know that even if we didn't get a 10, we know that that's as fast as that flow meter or level meter will run, because the level meter is actually gravity fed down here. So if it's gravity feed, you can't do this if you had a pump on it, that wouldn't work, but in our example here it's gravity feed, so we have to take it with the tank all the way full. And so now we have a difference. We said we had a full volume of 2,339 liters. We will subtract that from this grab, and we'll see that the difference is 2,207, and that gives us a drop of 132 liters in 2 seconds. We'll divide that by 2, which gives me an average of 66 liters per second, and that would be my max scale. So in the next part of the exercise, when you drop your add-on in, you would add input min of 0 and input max of 10, because that's what our raw data is coming in from factory I/O, and then a scaled value, since 0 is 0 liters per second, we would add then 66. So the first thing I want to do is drop a line in, and I can go up to my add-on instruction, and I have the SCP, so I'm going to drop it in, and so now I'm going to input those parameters I had and give it an output rate. And so you go ahead and get the parameters that we discussed earlier and put those in. At this point, pause the video, and then I'll resume with it working. At this point, I've dropped my SCP in, and I've entered all of my value. I just type them in. The first thing before you can enter anything is to give it a name and then create that tag, and then we can populate the rest. we use 66 liters per second as our max flow rate. If I want to see what's inside an add-on instruction, I can right click on it and I can go to open instruction logic, and this will give me a real-time view of what's going on inside there in the computations. So at this point I'm going to go ahead and I'm going to fill up my tank all the way up, and once it's full I will drain it, and our output should be our liters per second coming out of the tank. So as gravity, you get less volume in the tank, it will drop. So we're going to hit stop and then we'll begin to drain. Should start off close to 66 is what we calculated. Then as the volume comes down and the tank is completely empty, we will get 0. So if I want to, I can simply go back to the logic here and I will see the liters per second as my tank begins to drain. And we'll see the tank begin to drain here. And if everything's correctly, once the tank is completely empty, this should say 0. There should be no input. Here's our raw value data coming in. And now we're slowing down to a small trickle, and we're almost completely empty. We look, and pretty close to being empty. Now I see that I have a raw value coming in from the sensor here on Factory I/O. I'm not quite sure what that's about, but if that should be 0 because the tank is empty, but I'm showing a float value. So if this were an analog 0 to 10 volt signal, I would have a little bleed off voltage. So now that it's all the way empty and I want to say this to be 0, I need to take that float value that we had from the analog sensor. Even though it's not putting anything out, we've got a little bit of float value. So I'm going to come over here and I'm going to copy that value out, and under the input minimum I will paste that value in and then assemble the edit, and now I should show a 0 flow rate. So now we can test it once again. If we go back to the panel, we can fill this up a little bit. We'll hit stop and now we'll drain the tank, and we'll see that it comes up, and hopefully now once it's completely drained we display a 0 value there. And so the way I pulled the min value is probably more accurate than what you would get on the diagram, because we're actually reading the resistance of the wire, the manufacturing processes of the card. Factory I/O may have some inconsistencies here, so it looks like this time it did say 0. So we don't know why that was that, but if you do have that, the example still stands that we should have had a 0 in here. So that concludes this portion.